How do waves race through solids, liquids, and gases? Have you ever wondered why thunder takes longer to reach you than lightning, even though they happen at the same time? The answer has everything to do with how waves travel through different materials. This is one of those cool science facts that explains something you've probably noticed your whole life but never really thought about. In this video, we're going to explore why waves behave so differently depending on what material they're moving through. Here's something that might surprise you. Waves don't always move at the same speed. The speed of a wave depends on the medium it's traveling through, whether that's a solid, a liquid, or a gas. This is true for all kinds of waves, including sound waves and seismic waves from earthquakes. So which materials let waves zoom through the fastest? The answer will very likely surprise you. Waves actually travel fastest through solids, slower through liquids, and slowest through gases. Here's a real example. A sound wave moves through steel, a solid, at about 5,000 meters per second. Through water, a liquid, it slows down to about 500 meters per second. And through air, a gas, only about 340 meters per second. This seems strange at first, because solids feel so dense and packed together. Shouldn't that slow waves down? Actually, it's the opposite. To understand this, we need to think about how particles are arranged in different materials. In a solid, particles are packed super close together, like students standing shoulder to shoulder in a tight line. When one particle vibrates, it immediately bumps into its neighbor, passing the energy along almost instantly. The particles are also held in place by strong forces, which means they can vibrate and pass energy along without wasting time moving around. In a liquid, particles are still close together, but they have more room to move around and slide past each other. The particles have to move a little farther before they can bump into the next one. That's why waves move slower in liquids than in solids. The particles aren't locked in place like in a solid, so the energy takes a bit longer to transfer from one particle to the next. In a gas like air, particles are spread far apart, like students scattered across a huge playground. When one particle vibrates, it has to travel a much longer distance before it can bump into another particle and pass along the energy. That's why sound waves travel slowest through gases. There's so much empty space between particles that it takes much more time for the wave energy to get passed along. So remember, the arrangement of particles makes all the difference. Solids with their tightly packed particles let waves race through quickly, liquids slow things down a bit, and gases make waves take their time because particles are so far apart. Next time you see lightning and hear thunder seconds later, you'll know exactly why there's a delay. The light reaches you almost instantly, but the sound has to travel through all that air, bumping slowly from particle to particle until it finally reaches your ears.